Hey guys, in 1711, Alexander Pope famously said, "To err is human." He was only 4 feet 6 inches, but despite that, it is still possible that he was correct. For example, we used to think the Earth was 75,000 years old and in the middle of the universe. We also used to think the dinosaurs looked like this. It turns out, we are almost certain that every species of dinosaur contained at least some amount of feathers. Ridiculous! The point is, humans make mistakes, and the scientific conclusions of today quickly become outdated tomorrow. Now more than ever, scientific consensuses change very rapidly due to the amount of researchers making an effort to produce a number of high-quality studies for the benefit of the human race, and for the bottom line. When the family of noble gases were discovered in the later 1800s, it was observed that none of them readily formed any compounds, and it was initially believed that they were all noble gases, meaning they couldn't form any compounds. The noble gases are here on the periodic table, which means they all have their outer electron orbits filled. Elements react with other elements to form compounds because they want to have a filled outer orbit. Because the outer electron orbits of the noble gases are filled, there is no incentive for the noble gases to bond with other elements because they already have what they're looking for. But that doesn't stop scientists from trying. Because heavier noble gases have more electron shells than lighter noble gases, they are more subject to the shielding effect, which means the wider electron shells are in space, the weaker the attraction between electrons in the nucleus. This results in an ionization energy low enough to form stable compounds with the most electronegative elements, fluorine and oxygen. Ionization energy is the smallest amount of energy needed to remove the most loosely bound electron of an isolated gas atom. So, lower ionization energy means it's easier to remove the outer electron, which means it's easier to bond noble gases. The first report of a noble gas compound being synthesized comes from 1962, when Neil Bartlett realized that the highly oxidizing compound platinum hexafluoride ionized oxygen, O2, to O2+. Ionizing O2 to O2+ required an ionization energy of 1165 kilojoules per mole, while ionizing xenon to xenon+ required 1170 kilojoules per mole. Realizing the ionization energies were similar, Bartlett was able to freeze the xenon and get it to react with the platinum hexafluoride, forming xenon platinum hexafluoride. Even noble gases, when forced into their solid form, decide huddling with other elements isn't such a bad idea. Xenon, the largest stable noble gas, reacts far more easily than others because its electrons are only loosely bound to its nucleus. To get smaller noble gases to react, chemists had to drastically screw down the temperature. Krypton put up a good fight until about -240 degrees Fahrenheit, in which superreactive fluoride latched onto it, forming krypton difluoride. However, getting krypton to react was like making a baking soda volcano compared to how hard it was to get argon to react. After the xenon compound in 1962 and the krypton compound in 1963, it took 37 frustrating years until Finnish scientists finally pieced together the right procedure for argon in the year 2000. It was a delicate experiment involving frozen argon, hydrogen gas, fluorine gas, a highly reactive starter compound cesium iodide to get the reaction going, and well-timed bursts of ultraviolet light all at -445 degrees Fahrenheit. If it got a little warmer, the compound would collapse. Nevertheless, below that temperature, argon fluorohydride was a durable crystal. There are some instances where neon gas and helium gas, the two lightest noble gases, would bind and then unbind rapidly to hyperreactive compounds to form unstable helium and neon compounds. However, there is yet to be an instance where scientists have developed a stable helium or neon compound, and scientists are confident that even in the coldest regions of space, tiny helium and neon have never bonded with another element. So, for now, argon wears the belt for the hardest element humans have ever forced into a compound. The moral of the story is scientific consensus changes day to day, and what is thought to be impossible today quickly becomes possible tomorrow. In conclusion, scientists are often incorrect with their assumptions of the universe, and sometimes, to find the whole story, you have to wait for all the evidence to be discovered. Bye everybody.